we are deriving for the capacitances of capacitor, different kind of capacitor. First we started with the spherical ball kind of capacitor, and then we derive expression for cylindrical coil or cylindrical wire capacitor, which are there like finite distance apart, and one plus q wire, another is a minus q wire. We derive the expression for that, and then we jump into the spherical capacitor, which has like two medium. One is epsilon medium, another is another different medium. Now today we are going to derive expression for a capacitances of this concentric spherical capacitor. So this is the concentric spherical capacitor. We have an inner sphere of positively charged and the outer sphere negatively charged, and in between these two sphere there is a dielectric medium. Dielectric medium has a dielectric constant K. These are the dielectric medium. This is the full dielectric medium. Let me choose some different color. Here it will get mixed up with the existing color otherwise. So here these are the dielectric material is there within these two sphere. The dielectric constant of this dielectric material is K. Okay, then as usual what we will do, first we will find out the electric field inside this. This is our usual method. Okay, let's just start with the derivation. Let me choose some good color. Yeah, okay. The derivation means at the point P, at this point, this point, you find out the electric field first. So at this point you will find out electric field. Let's start from here. What would be the electric field at this point? This is plus q charge. Because of this plus q charge we will be having some electric field at this point, which is 1 by 4 pi epsilon naught. This is nothing but 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught q by x square into q by x square. This is the electric field inside the sphere. Correct? At point P, distance x from the inner circle, you apply Gaussian law and you will get this expression. Fantastic. Now we need to find the potential difference between these two conductor. You can say between the outer surface of the inner shell to the inner surface of the outer shell. The potential difference between these two, it means we need to find out the V. V will be equal to, from R1 to R2, integration of E with respect to dx. R1 is the radius of inner sphere and R2 is the radius of outer sphere. We just find a derivation, integration of this. You will get 1 by 4 pi epsilon naught. Sorry, it's not working here. Let me write it again. 4 pi epsilon naught into K. Actually here you will have K also. K divided by x into q. This will be q. This is the expression. Now you need to find out the C. Q is equal to CV. So you know Q is equal to CV. Q will be equal to CV. Sorry, CV. So it means your C will be equal to this X. Actually this X will move from R1 to R2. Okay, this is a definite integral, and you will get the value Q by 4 pi epsilon naught R2 minus R1. Okay, now value of C will be equal to 4 pi R1 minus R2 into R1 R2. Here you will have R1 R2. Why? Because it is 1 minus R1 minus 1 by R2. Okay, there is something wrong in this expression, I guess. Let me correct it. Just 1 second. This is wrong. Let me erase this horrible wrong expression. Yeah, let me correct it. So this one is nothing but you will take constant out 4 pi epsilon naught. 4 pi epsilon naught, what is that? I don't know. Oh, it is getting there. Okay, fine. 4 pi epsilon naught K, this is the constant. Take out 1 by R2 minus 1 by R1. Got it? And here you will get minus sign, because 1 by x square. What happened to this? And here you will get some minus sign. Okay, now next. This will be equal to R2 minus R1 1 by 4 pi epsilon R1 R2. Then I'm writing the expression here 4 pi epsilon naught K R1 R2 divided by R2 minus R1 minus R1. So this is the expression. This is the expression for capacitance. Okay. Now see you on a next video.